In this class, we're going to take a look at the rules for indices. So remember that indices are just powers. So these are the rules for working with powers, or you might call them exponents. So you might call these the rules for exponents. All of those words mean the same thing. Essentially, we're dealing with numbers or algebraic terms which have got powers on them, and we need to learn how to combine the terms or how to manipulate them in some way. And to do that, to complete these examples, which we'll look at in a moment, we need a set of rules for indices. These are really important. These come up in a whole bunch of topics that you're probably going to do in the future. So if you end up doing like a pre-calculus course or a calculus course, these are just all over those. So working with the rules of exponents, the rules of indices, great skill to get down. Probably more important than surds. Radicals and indices tend to get taught together. But personally, I think that these are far more important than the surds. You should practice them as well, of course, but these guys are going to probably serve you better in the future. So the way that these work, there are sort of 3 or 4 primary rules and a couple of special cases to look at. So I'm just going to use letters to represent variables. So for example, let's use A, B, and C. In reality, your questions are probably going to use numbers, but they apply just as equally well if you're using letters. So let's say the first rule, you've got a to the power of b times a to the power of c. Notice the base numbers have to be the same. So these rules do not apply if you've got different base numbers. So a to the b times a to the power of c, that's just a to the b plus c. In other words, if you're multiplying two terms with the same base number, you can combine those into a single term and add the powers together. So multiplying, add the powers. Similarly, but conversely, I guess, a to the power of b divided by a to the c, not too difficult to figure out. You subtract the powers. So multiply, add the powers, divide, subtract the powers. Remember that in theory, these rules go both ways. So you could take one term and split it up by going back this way. You could take a term that looks like that and split it up. That's unlikely to happen in these because remember, this will be a whole number. This could be like 12 or something. You wouldn't necessarily want to split that back. Usually you'd be going the other way because you wouldn't necessarily know what factors you want to make it into. So if it was adding together to make a 12, do you choose like an 8 and a 4 or an 11 and a 1? So we tend to go the other way with these. But like any rule, any equation, it could go both ways. So those are probably your 2 primary rules. The next rule, if you've got a power in a bracket with another power, so sometimes called like a power on a power, then in that scenario, you just times the 2 powers, you multiply them. So a to the power of b, c. And again, that one goes back the way as well. So those are probably our 3 primary rules. There's a couple of special cases. So anything to the power of 0 is 1. Doesn't matter what that base number is. It could be a very large number. 1,000,000 to the power of 0 is 1. 1,000,000,000 doesn't really matter. It could be a negative number. It could be a decimal. The number pi, any number to the power of 0 gives you 1. So that's a good result to know. And then finally, if you're working with negative powers, so if you've got, say, a to the power of minus b, working with negative powers is quite difficult because say you had an example like 4 to the power of minus 2. Well, to compare that with 4 to the power of 2, what does 4 to the power of 2 mean? That means multiply 4 to itself 2 times, so 4 times 4. That's quite logical, so this means multiply 4 to itself. This guy though, how do you multiply 4 to itself minus 2 times? That's kind of weird, right? So we need a way to be able to process this, and it turns out that this rule is that you just turn it into a fraction and change the power to a positive. So 4 squared, 4 times 4 is 16, so this guy would end up being 1 over 16. So the rule here is to turn it into a fraction and change the power to a positive power. That would work the other way around as well. So say, for example, you started off with a fraction and the power was a negative on the denominator of the fraction, so 1 over a to the minus b. That, again, you cannot process that negative power easily, so we would turn it into a positive power by bringing this up to the top of the fraction to get a to the power of b. So generally with that rule, we're going to be turning the powers from negative to positive rather than positive to negative, because we know how to process positive powers Negative powers are far more difficult to kind of conceptualize in our heads. So these are the rules for indices, the rules for exponents. Really important. Take some time to learn them, and more importantly, take some time to practice applying them in different scenarios. So let's take that theory and apply it to these examples over here. So this one here, check that you've got the same base numbers, which we do. If that was a 3, for example, or some number other than 2, then the rules don't apply. But this is just basically the first rule. We're multiplying these together. So we can just go ahead and say that's going to be 2 to the power of 3 plus 4. Generally, we're not going to write in that. We're just going to go ahead and add them. So that's going to be 2 to the power of 7. So I really just put that line in there for illustration. You will generally not include that line of working because you don't need it, because you can just go ahead and add those powers. It's quite easy. This guy here, we've got a power on a power. Well, in that scenario, that's when we multiply the powers together. So that's just going to be 4 to the power of 10. So I could write a line where I write 4 to the power of 2 times 5. Don't need to do that, it's overkill. It's just going to take too much time. Just straight to 4 to the power of 10. Okay, next one's a negative power. So again, how do we conceptualize multiplying 3 to itself minus 2 times? That's quite difficult. So we just use a rule where we turn it into a fraction. So 1 over 3 to the power of positive 2. 3 to the power of 2, 3 squared is 9. So that just becomes 1 over 9, and we're done. Final one doesn't seem to fit in with any of the rules because there are no fractions over here apart from in the final rule, but it's not quite the same thing. But just remember that this fraction is just really a shorthand way of writing divide. So really what this is saying is 5 to the power of 4 divided by 5 to the power of 2, which then means that the second rule applies, and we can just combine those by subtracting the powers. 5 to the power of 4 minus 2, which is 5 squared. Sometimes these questions might ask you to process these all the way to a final number. So for example, in this case, 25. Sometimes not, and you'll just be asked to write it as an index, basically with a power. So really, really important, these rules. I would recommend spending some time making sure that you really understand these, and then trying a variety of question types, especially the ones that you don't like the look of, the ones that look a little bit ugly, because you are definitely going to see difficult scenarios with these in the future. So it's better to go through the pain now and get down with these, and it'll just make everything easier in the future. So check out not only a few questions on this, but a whole bunch of questions.